Hello, for today's video, these students are going to perform such activity about the earth. So as you can see, they are performing the seismic waves as represented by the wave box. Okay, so yeah, this is it. So for the materials, they have to prepare the paper clips, yarn, and also this box, ruler, tape, scissors box, and also they have to prepare a basin of water and stone. Okay, and also elastic ruler. Okay, yeah, you have to perform like this, and later we will explain what they are doing about this activity. So let us start. Okay, so again, for the learning task number 1, they have to prepare a basin with half-filled water and stone. So they have to drop a stone into the basin and observe what will happen. So what happens when you drop the stone? Of course, as you can see, when the stone drops into the water, it forms ripples. What causes the ripples to form? The ripples form as the water molecules oscillate in a small circle. And another question is, how far does the ripple continue? The ripple continue when the amplitude of the ripple will drop with a factor proportional to the square root of the perimeter of the expanding wavefront. It is explained by the fact that the energy that created the wave came from a point where the rock dropped, and as time goes, this energy gets spread over a larger and larger circumference. For learning task number 2, using 12-inch flexible plastic ruler, hold the ruler horizontally at both ends and then bend the ruler. Do you feel the ends of the ruler pushing against your hands? Of course, yes! And that push is the energy, and it is stored as the ruler bends. So, now, if we're going to release the ruler, so what will happen to the ruler as you release it? And of course, as you can see and observe, the ruler straightens out. And we can say that the ruler is elastic since it goes back to its original shape. And when you hold one end of the ruler firmly with your right hand and bend the ruler again with your left hand, so as you can see, energy is gained, stored in the bent ruler. And while keeping a tight grip with your right hand, take away your left hand quickly. So what will happen to the ruler as you take away your left hand quickly? Of course, the ruler vibrates as it snaps back to its original position, and that stored energy is released. So now let us perform the next and last activity, which is learning task number 3. So what they need to do in learning task number 3 is to create a wave box that demonstrates how earthquake waves can travel through a variety of materials as they travel away from the focus of an earthquake where the rocks first rupture. Okay, so first they have to remove one side of the cardboard box, punch a hole in the top and bottom of the box using a nail or ice pick. They have to tie a string so it runs from top of the box to the bottom of the box. So they have to start by tying a string to a paper clip on the outside of the box at the top, and thread the string through the bottom of the box and tie the string to a paper clip on the bottom of the box. So they have to prepare or to place 4 to 5 or 6 paper clips on the string inside the box, and then place the box on the table or some other object that they can strike to make it vibrate. They have to strike the table hard enough to cause energy waves to travel through it to the box, and they have to move box to another surface and see if they can make the paper clips vibrate on these surfaces. And then of course they have to change the experiment by using different thickness of string and change the experiment by using different sizes of paper clips. What will happen to the paper clips if you have struck the table hard enough? The paper clips will move due to sudden vibration. And why does vibrations create sound? Of course, because sound waves are formed when a vibrating object causes the surrounding medium to vibrate. Remember that vibrations are able to travel faster through a solid. So since the molecules are closer together than through a gas whose molecules are further apart. So this is why it is easier to hear the sound of a paper clip being dropped through a solid, which is the desk, than it is when the vibrations are traveling through a gas or air. And if you have struck the table hard enough, the paper clips will start to vibrate back and forth. And then if you move your box to other surface and see if you can make the paper clips vibrate on these surfaces. You can also change the experiment by using a different thickness of string. And of course, sound is produced when an object vibrates, thus creating a pressure waves. And these pressure waves causes particles in the surrounding medium like the air, water, or solid to have vibrational motion. So as the particles vibrate, they move nearby particles, transmitting the sound further from or through the medium.